colleagues, welcome to the new interview at Rosmould channel. Rosmould is a unique trade fair dedicated to mold and tool making in Russia. Rosmould has a very dynamic and interesting special section, 3D tech. It's all about additive technologies and 3D printing. It is held in cooperation with the Formnext and the German Association with the MA Working Group Additive Manufacturing. And today our guest is Enrico Gallino, Senior Engineer, Ricoh 3D. Hello, Enrico.
Hi, Daria. Thank you for inviting me today.
Thank you for coming and nice to see you. So on our channel, we study real cases in additive manufacturing, new research, technologies and materials. Right now we will talk about the materials. So please subscribe our channel to watch new interviews. So my first question is, could you please tell about Ricoh, like shortly, what are you doing and what do you produce?
Yeah, so Ricoh is a large Japanese company that is focusing originally on 2D printing. So the move to 3D printing has been something natural for us, and we are also now developing a wide range of digital service. And more particularly, Ricoh 3D is the 3D printing business for Ricoh in Europe. And what we offer to our customer is a 3D printing service, so printing parts for our customer and helping those customers not only for their prototyping needs, but also to use additive manufacturing for serial production of component, which is something we see more and more companies doing.
So more precisely, more detailed about the material which was used in 3 cases that we will describe further.
Yeah, so we in our service we offer a wide range of materials, but more particularly what we are probably more known for is our polypropylene. So we have been printing polypropylene with selective laser sintering technology, so a powder bed fusion technology since 2015. And if you let me share my screen, I will give you some additional information for this material. So polypropylene is a material that is widely used in the traditional manufacturing technologies like injection molding, for example. It's a material that is well known for its chemical resistance. So it's a material that can resist a wide range of chemicals, acid, base, or even oils. And it's a material that is widely used in several sectors like packaging, automotive, medical, for example. And if we look more specifically at our material, one of the key properties is definitely a very good flexibility, so high elongation of the material. And in this slide, you can also see the material in action.
Can I ask a question?
Yes.
What characteristics and maybe structure makes this material with these characteristics?
I would say in terms of material composition, this material it's a copolymer, which makes the sort of the elongation of the material quite high, or generally higher than other polypropylene on the market. And also by its the shape and the size of the powder, used for this material. This enabled to print part with high density, parts that are watertight, up to 10, 15 bar. We've got customers that have tested the parts up to this level of pressure, and we can achieve those watertight and airtight properties without any specific post-processing. So the parts came straight out from the printers with watertight and airtight properties. And also we have tested the material doing some fatigue tests, so testing the durability of the material on the long term, and we know that the material is able to withstand up to 1 million cycle in fatigue without any major and significant degradation. And also polypropylene is a material that is lightweight. It also not absorb any moisture, so it's very versatile, material.
Mm-hmm. Okay, thank you so much. So let's start with the Toyota case study. In this case, was used this material or another?
No, still polypropylene.
Okay, so please describe.
Yeah, so here we can see one of the work we've done with one of our customers, so Toyota, where by using our polypropylene, they've been able to do some functional prototyping work to validate a number of the design of a number of exterior components for fit and function for a Toyota Corolla. So here the benefits that Toyota is getting from using our material is that they can do their functional prototyping validation using the same material that they will use for final production. Also, the material has got properties that are similar to an injection molding polypropylene, so that's another benefit for Toyota. And also, obviously, one of the key benefits from 3D printing is that they can shorten their product development cycle from several weeks to just a few days. So they can have, starting from a design, from a CAD model, their parts in their end for the testing in just a few days, and even printing quite large parts is not a problem, because with our machine we can print quite large part, up to 500 millimeter in length. Or if we got parts that are larger than that, we are also able to join a section of parts together with a process that we have developed in-house, and we keep improving over time to offer to our customer a even more robust process and parts.
Okay, is it possible to make serious manufacturing with this material in 3D printing?
Yes, absolutely. And actually, if we move to the next case study, okay. We've been working with Volkswagen, another large automotive manufacturer. So Volkswagen, similar to Toyota, they've originally started using the material for prototyping, but then over the course of time, they realized, as I said before, that the material has got properties very similar to the injection molding materials they've been using, and also it's also possible to join together injection molded part with 3D printed part using conventional joining method like ultrasonic or laser welding, for example. This is something that is, for example, not possible to do with nylon 12, which is a very popular material in powder bed fusion technologies. So since they realized that, they've started considering the using of polypropylene for small serial production. So Volkswagen, they also produce some special vehicles for the police or for ambulance, and so they started producing components for those special vehicles where the annual production volume are relatively low. And we got here an example of a glove box that is produced for one of those special vehicles. So they've tested also the performance of the glove box, and again realized they can use the material and achieve a fatigue test. So basically opening and closing the glove box 20,000 times at a different temperature without any issue.
Could you please tell where exactly was such production in Toyota and in Volkswagen? I mean, geographically, in what country?
Yeah, so we are based in the UK. So for Toyota, they are based in Belgium. So it's quite close. So they use our service. And for Volkswagen again, it's an historical customer for Ricoh. And again, logistically again we are not too far away from their facilities in Germany, so we have supplied those components to them, and again in very short time we are able to provide them with these components.
And if it is not commercial information, approximately how many tons of this material should be sent to the customer, for example, to Volkswagen?
It really depends on the customer. We have worked on project where we have printed even larger volume of parts, like 1,000 parts of a single components for a customer. We really see 3D printing starting to be used more and more for serial production, and the volume could be very different from application to application, but the advantage is that you don't have to invest in a tool, for example, to produce your parts. So it's very flexible in terms of technology.
Okay, thank you so much. And what about the color? Is it fixed, or you can change the color? I mean, of the end detail.
Yeah, for Toyota, we have worked now on a few models, so doing a similar job on printing components for functional prototyping and validation on several models. Again, we can print parts with all sort of size and shape. So again, it's quite flexible, and always keen to support our customers when they need our service and our materials. So this is again a very exciting project and collaboration we are proud to support. So Gravity Industries is a UK-based company that has developed a jet suite that you can see on this picture, and I will also share a video later on to see the jet suite in action. So as you can see on the pictures here on the slides, we have printed several components for the jet suites, again leveraging the capability for printing large parts. So you can see we have printed those white components here that are used to house the engines of the jet suites, and we've also printed the backpack of the jet suite. And again, here we can see some of the benefits of polypropylene in action. In particular, its durability, the flexibility of the material, which make it easier to sort of mold the design around the human body, and is also a very lightweight material. So Gravity, they are also now developing an electric jet suites, where again reducing weight is very important to improve the efficiency of the jet suites. And also when they develop the different component, they can very quickly iterate the design, check if everything is working okay, and if a change is needed, they can very quickly do the design modification, and again getting the parts in hand in a matter of days. And also by using 3D printing, is also possible to significantly reduce the part count. So it's possible to consolidate several components into one, so less resources and time needed to assemble the different components. So again, it can really speed up the development and the production of the jet suite.
These jet suites, are they used in common consumption or in individual orders?
There are several applications for these jet suites. I would say one is, for example, recreation, so doing shows where the pilots can fly and showcase the capability of the jet suite. But there are also some more sort of practical application. There are some application potentially in the military and defense industry, but one application that I particularly like is the use of the jet suite, for example, in paramedic operation. And I can share a video showing the jet suites in action in this type of application. So you can see here the jet suites using in a rescue mission, where you might have someone that is injured in a remote area where is a lot difficult to go and see those people in those remote areas, so difficult to access. And actually with the jet suites is possible in a matter of minutes to fly and attend those people, check if they are okay, assess if everything is what they need, what is the support required from a medical point of view. So in a matter of minutes, we can be very responsive to help people in a remote area, and then deploy the rescue service accordingly. As you can see here, in just 70 seconds, it's possible to arrive on site and, as I was saying, assess the situation, see what kind of help is required, and stabilize the patient, and obviously then call the medical team and to provide a rescue to the people.
And in a matter of rest, it is a very good view. And
I think that you can clearly see the benefits for this type of application, and I think those type of application, I think it's something we will see more and more in future, being so effective solution for this type of application.
What about the weather? Is your material resistant to all temperatures, or of course maybe some extreme temperatures could occur?
In terms of operating temperature, so the polypropylene can be used between, I would say, temperature below zero, and its melting point is around 120 degrees. So I would say in between this range of temperature, their material could be used safely, and obviously, if some load is applied on the material, the range of temperature obviously is a little bit narrower. But for, let's say, for application in the automotive sector, for example, for exterior or interior components, the material it's absolutely fine. The same for medical application. Where the material is in contact with fluids, it's as long as the fluids are not very hot, in general, the material is okay to use.
Okay, thank you so much, Enrico, for such detailed explanation, and I hope we will see you again with new cases. Rosmould will be held on 7th till 9th of June in 2022 in Moscow. So I invite everybody to come see you at Rosmould.